Okay, here we're going to look at specifically the sum and difference identities and how we use these identities in order to evaluate our trig functions. Alright, so the first thing I want to point is that most textbooks or books, when you're looking at the sum and difference identities, they set them up so that you have, for your sign, you've got u plus and u minus. So the reason they do that is to kind of shorthand. So I wanted to show you how to navigate through the shorthand of what your textbook is trying to say. And the important thing is that when you're setting up your sum and difference, you go top to top and bottom to bottom. So that is talking specifically about your signs. So I tried to highlight them here so that you can see how we would match them up. So here, if I want to do the sine of u plus v, then I would expand that out to say the sine of u sine of v, or sine of u cosine of v plus the cosine of u sine of v. Whereas if I subtracted, I would subtract. Now you would think that that would just be normal throughout, but it's not. If you take a look at cosine, if I want to use the sum identity for my cosine, notice I would have cosine u cosine v minus sine of u sine of v. And if I did the difference of cosines, I would then add them. So sometimes your identity is the opposite. So as long as you simply remember top to the top, bottom to the bottom, then no matter what textbook you use to try and reference your sum and difference identities, you'll always be able to figure out what identity goes with which trig idea. Now the same happens for your tangent. Notice if I did my sum for my tangent, on my numerator I would have tangent plus my tangent, but my denominator becomes 1 minus the tangent u tangent v. Whereas if I did my difference, I would have tangent u minus tangent v on the top and 1 plus tangent u tangent v on the bottom. So again, that method of top sine or operation to top, bottom operation to bottom is going to hold through. Now for some of these, when you are asked to use the sum and difference identity to solve a problem, you'll find out that you can solve it more than one way. And that's going to be the true for this first one. So I'm going to show you how we can first solve this using a difference identity, and then I'm going to show you how we can solve it using a sum identity. Okay. So here, the first thing that we want to look at is we have 13 pi over 12. Now, the reason we use sum and difference identities is because we want to be able to come and reference back here to our unit circle. So notice I have a unit circle here, and what's cool about this particular circle is I have the degrees, I also have my radians, but I have my xy values. And this is helpful when creating those triangles. Okay, so if you look, if we're looking at our radians, notice none of them show a 13 pi over 12 anywhere. In fact, the biggest denominator that we have is over 6. So I want to look at what two angles in my unit circle could I use that when added or subtracted from each other come up with 13 pi over 12. So here, one of the things that I know that I have is I would have 4 pi over 3 minus pi over 4. So if I look at this, if I were to use my fraction rules, which say I need a common denominator, I'd have to multiply this first part by 4. So this is going to end up giving me a 16 pi over 12. And I'd multiply the second part by 3. So here we would end up having 3 pi over 12. And if you do the math, we get 13 pi over 12. Now what's important about that is this sign right here. Okay, so this tells us what we're doing, as well as this trig function here tells us which identity we're using. So we're using sine and we're using the difference of. Okay, so here that means we are going to use sine of u minus v, which is going to equal the sine of u, the cosine of v, minus the cosine of u, the sine of v. Okay, so that's the identity we're going to use. So here we have to identify what is u and what is v. Well, if you look at the way it's written in your parentheses and the way we wrote it out to solve for our angle, we're just simply going to slide the two together. So what does that mean? It means that 4 pi over 3 is my u and pi over 4 is my v. So we can rewrite this to say the sine of 4 pi over 3 minus pi over 4. So this is going to end up being the sine of 4 pi over 3 cosine of pi over 4 minus the cosine of 4 pi over 3 and the sine of pi over 4. So this is where we're going to go ahead and use our unit circle. So if I pull this over, I want to look strictly at 4 pi over 3. So I'm going to come in and I'm going to look around and I'm going to look for where I find 4 pi over 3, which is right here down at 240 degrees. Okay. So if I'm looking at this, I can draw myself my triangle and I have my x, y values to go with it. So I'm down here in the third quadrant. So when I'm looking at that 4 pi over 3, I'm using my third quadrant here. So I can draw in my little reference triangle. So I can drop in my thing. And then I have my vertical and I have my negative. Okay, so here would be my angle. And we're told that my x is going to be negative 1/2 and my y is negative square root 3 over 2. Okay. Of course, it's a unit circle, so that makes our radius 1. So I'm looking at the sine of 4 pi over 3. So the sine is going to be opposite over hypotenuse. So this is going to end up being negative square root 3 over 2. And then I have pi over 4. So I need to figure out what my pi over 4 is going to be. So you come back to your unit circle. Pi over 4 is found right here. It is my 45 degree, which has the same x and y value. So you can draw that reference triangle to help, or you just know what it is. If we were to draw it, we would have our reference right here, where we would come straight out, and then we would drop down. Again, my radius is 1. This is my angle, and we were told this is square root 2 over 2, and square root 2 over 2. This gave you pi over 4. Okay. So my cosine of pi over 4 is going to be adjacent over hypotenuse. So this is going to be times the square root of 2 over 2. We're going to subtract. Now I need the cosine. So if I come back here to 4 pi over 3, cosine is adjacent. So this is going to be negative 1/2. And I need the sine of pi over 4. So again, over to pi over 4, and we have opposite over hypotenuse. So square root 2 over 2. Now if you notice, the biggest thing that I did here to try and help myself out was I drew my reference triangles so that I could figure out my angles. All of these problems are wanting you to find answers exactly, which means we don't want decimals. What this essentially means is we do not use our graphing calculator to try and find it. Instead, we have to find it using our unit circles and using reference triangles. Now once I'm done with this, all I have to do is finish the math. So we're going to go ahead and just simply do that. Across the top, I have a negative. Square root of 3 times the square root of 2 becomes square root 6. 2 times 2 is 4. Here I have minus a negative. This becomes positive. 1 times the square root of 2 is the square root of 2. 2 times 2 is 4. So we can rewrite our solution here to be the square root of 2 minus the square root of 6 all over 4. And that would be your first solution to finding or using the sum and difference identities to find the sign of 13 pi over 2. Now if you remember, the first thing I said was that we could do this two ways. So I showed you how to do it using a difference. Let me show you how to do it using a sum. So I still want to find the sign of 13 pi over 12. And in this case, I want to use I want to go ahead and use my unit circle in order to find a sum. So in this case, when I'm looking at my unit circle, so again I would reference my unit circle, I am looking for pi's that when added together are going to give me my 13 pi over 12. So again, I have to be able to create that since none of them are over 12, and one of the ways that I can do that is by using 3 pi over 4 plus pi over 3. So if I were to do the math there, in my first fraction, oops, can't see that, in the first fraction, I have to multiply both by 3. So this ends up giving me 9 pi over 12. I'm adding, and in the second I have to multiply by 4, so this becomes a 4 pi over 12. 9 plus 4 gives me that 13 pi over 12 that I was looking for. Okay. So again, just like before, the first part is u, the second part is going to be v. So here I'm going to look at the sign, and I'm looking at 3 pi over 4 plus pi over 3. So because I'm using the sum, this is going to become the sine of u, the cosine of v, plus the cosine of u, the sine of v. So we're going to plug our information in. So here this is going to give me that I want the sine of 3 pi over 4 and the cosine of pi over 3 plus the cosine of 3 pi over 4 and the sine of pi over 3. So just like before, we can use the idea of our reference angles. So I want 3 pi over 4, so I'm going to come over here to my unit circle and I'm looking for my 3 pi over 4, which is right here. It's in my second quadrant and it has these xy values. So here I could go ahead and draw out my reference. So I'm here in my second quadrant. I can drop down my vertical. Here's my angle, and this is 3 pi over 4. And so we know this is going to be the square root 2 over 2 and negative square root 2 over 2. Now the other reference I have to use is pi over 3. So again, if I come back and look at my unit circle, notice I have pi over 3 right here in my first quadrant, and it has the matching 1/2 square root 3 over 2. So I can go ahead and draw that reference triangle as well. So again, we're in quadrant 1. This is my angle. We're looking at pi over 3. And here we're going to use that this is the square root 3 over 2, and this is my 1/2. So I have to use my reference to fill out my equation. So for the first one, I want the sine of 3 pi over 4. So sine is opposite over hypotenuse. So this is going to be the square root of 2 over 2. Then I want the cosine of pi over 3. So cosine is adjacent. So this would be times my 1/2. I'm adding. I want the cosine of 3 pi over 4. So again, that's going to be adjacent. So here's going to be negative square root 2 over 2. And then I want the sine of pi over 3. So that's opposite. So here I've got the square root 3 over 2. Now I need to do the math, so I'm going to go ahead and multiply. The square root 2 times 1 is going to give me the square root of 2, and 2 times 2 is 4. Plus a negative makes this subtraction. Square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Again, I can put it all together, and this gives me the square root of 2 minus the square root of 6 all over 4. Now, if you notice, it's the exact same result that we got on the first page. So here you go. We were able to solve 13 pi over 12 using two ways, either the sum or the difference of angles. And remember that key is being able to use your unit circle. Now sometimes you're going to come into equations where you can't find two methods, and so here I want to do the tangent of negative 120 degrees. So I have to think about how can I get to 120, and not only that, I want it to be negative. Okay. So when we're looking at our unit circle, everything is positive. So there's a couple things that I have to pay attention to. Okay, the first is I want negative 120 degrees. So if we look, if I start at 0 and rotate up, my 120 falls right here. So we went 90 plus an additional 30. Well, one of the things that I need to do is go negative. So I have to go negative 90 and an additional 30. So I'm looking technically around this 240 degree mark to be my negative 120. Well, mathematically, using the angles that we have on the unit circle, one of the easiest ways to get there is going to be to start at 30 degrees and subtract 150. Okay, so if we were to do that, then we would have that I want the tangent of 30 degrees minus 150 degrees. So if you were to do the math, that does give you negative 120. So that would mean my 30 degrees is going to be my u, the 150 is my v, and I want subtraction. So again, this piece here is going to be a huge part as it tells you what to do. So we are looking at the tangent of u minus v. So we would evaluate or look at our identity. So this is going to give you the tangent of u minus the tangent of v all over 1 plus the tangent of u, the tangent of v. So we have to plug in our information. So here we're going to get that the tangent of 30 degrees minus 150 degrees is going to be the tangent of 30 degrees minus the tangent of 150 degrees all over 1 plus the tangent of 30 degrees and the tangent of 150 degrees. So I have my two reference that I have to use. So we're going to use 30 degrees. So my 30 degrees is going to be here in my first quadrant. So here's my angle, and this is my 30 degrees. And so we're going to look at this being the square root of 3 over 2 on the bottom and 1/2 up on the side with my radius of 1. Now 150 falls in my second quadrant. So here's my 150. We can drop down. So this is 150 degrees. Again, my radius is 1. And we're looking at 150. We're going to have negative square root 3 over 2 here and 1/2. So I've got my reference, and of course, again, we use the unit circle. So just one more time. Here's your 30-degree line. This is your x, this is your y. And here's 150. Again, here's your x and here's your y, and both of those will be able to create your reference triangles. Alright, so we have to just do the same thing we did with the others where we need to plug it in. So in this case, my tangent of 30 is going to be opposite over adjacent. So this is going to be 1/2 over the square root 3 over 2. I'm going to subtract away, and I want tangent of 150. So again, this is going to be opposite, so 1/2 over negative square root 3 over 2. Then we're going to have 1 plus. I already did the tangent of 30 on the top, so I can just rewrite it. So 1/2 over the square root 3 over 2. And the tangent of 150, so again we're going to have 1/2 over negative square root 3 over 2. So now we just have to simplify, and this is a lot of fractions. So the first thing that I would do is recognize that if your denominators are the same, then my numerators can stay. So my denominators are going to cancel out. Now that uses the idea that you're going to keep the numerator and use the reciprocal of the denominator. So here this is going to actually be 1 over the square root of 3. Plus a negative turns it into plus, and this becomes 1 over the square root of 3. This is 1 plus. Again, we can simplify 1 over the square root of 3 times 1 over negative square roots of 3. So if we continue simplifying, across the top, 1 plus 1 is 2, so this ends up being 2 over the square root of 3. Across the bottom, we're going to have 1 plus. 1 times 1 is 1 over. Square root of 3 times the square root of 3 is going to give me negative 3. If we continue simplifying, we have to combine or work with a fraction on the bottom. So if we look at just this bottom term here, this becomes 1 minus 1 over 3. To simplify that, we need a common denominator. So here this becomes 3 over 3 minus 1 over 3, which is going to give me 2 over 3 as a result. So here we end up with 2 over the square root of 3 over 2 over 3. Again, our rule applies, so if we were to keep the top and multiply that by the reciprocal of the bottom, we end up getting 3 over the square root of 3. Now, one thing we can do here is we can rationalize. So to rationalize a denominator says that you're going to multiply the top and the bottom by that denominator. And so in this case, we end up getting 3 square roots of 3 over 3, which is going to simplify down to just the square root of 3. And so here, our end result would be 3 square roots of 3. Okay. Now, I always like to tell students that sometimes when solving these problems, you are asked or told not to rationalize. If that's the case, then 3 over the square root of 3 would be your result. So you just kind of have to read very carefully the question you're doing to see how it is they want you to input your result. Alright, let's look at one more. This one is going to be slightly different from the other one in the fact that we are given our problem in a different way. And so here we're told that you have the sine of u is 3/5 and the sine of v is 4/5, and u is between 0 and pi over 2, and v is between pi over 2 and 3 pi over 2, and you need to evaluate. So the first thing you have to do here is make your reference triangles. Okay, so we have to look at what do we know. So we know for my first triangle I have the sine of u is going to be 3/5, and I'm told that it falls in quadrant 1. Why? Because it's between 0 to pi over 2. So I want to draw that triangle. So we would go ahead and input our little triangle into here. So we know this is our angle. We know that we're in quadrant 1, and we're told the sine of your angle is 3/5. Well, sine is opposite, so the opposite is 3 over hypotenuse, which is 5. Using Pythagorean's theorem, we can automatically state that this is that special Pythagorean's theorem triangle, which is the 3, 4, 5 triangle, so we know that this is 4. However, if you don't remember that Pythagorean's theorem has special triangles, you could use Pythagorean's theorem to find that missing side. Now we also have to do the sine of v, and we know the sine of v is going to be 4/5, and we know that it falls in quadrant 3, and the reason for that is because we go from pi to 3 pi over 2. So in this case, quadrant 3 would look like this. We could input our triangle in. Here is your angle, and we're told that it's 4/5. So again, this is going to be opposite, which is 4 over hypotenuse, which is 5. Lucky for us, this is still that same 3, 4, 5 triangle, so we can put in that missing side. But again, if you didn't know it, you would go ahead and use Pythagorean's theorem to find it. Now that we have our reference, we can go ahead and use the sum or difference formula we want. And so we want that the tangent of u minus v is going to be found by doing the tangent of u minus the tangent of v all over 1 plus the tangent of u tangent of v. And so with that, we can input our information. So here, the tangent of u, so this first triangle is my u. So this is going to be opposite over adjacent. So this is 3/4. Then I'm going to subtract tangent of v. Again, opposite over adjacent, so 4/3. And then I'm going to have 1 plus, my tangent of u was 3/4. My tangent of v is going to be, negative 4 over a negative 3. So that being said, my pause right here is because when you're making your triangles, one thing I should really stress is you want to make sure that your signs are correct, so that when you're inputting your values, you input the right signs where they need to be. Okay, so in this case, both my 4 and 3 of my V triangle are negative, so we would input those in as negative. And so the other thing that we would do here is now we have to reduce our signs and actually evaluate. So in this case, we would end up with 3 over 4 minus 4 over 3. And this is going to be 1 plus. Remember, because I have negative over negative, these technically turn positive. So here we're going to end up with 3 times 4, which is going to give you 12, over 3 times 4, which again gives you 12. If we continue to simplify, we have 3/4, so here we would use that LCD is got to be 12. So my first fraction, to make a 12, you multiply by 3. So this becomes 9 over 12, minus, for my second, we multiply by 4. This is 16 over 12. On the bottom, we know 12 over 12 is 1, so 1 plus 1 is 2. So here we've got 9 minus 16, which is going to give me a negative 7 over 12. The whole thing is over 2. Use those fraction rules, which say keep the numerator, multiply by the reciprocal of the denominator, and then multiply straight across. And this right here would be your result. So we found the difference, the tangent difference, given the information that was provided. Okay? So there you have it, everything that you need to know about how to solve our problems using your sum and difference identities, where you're either given the problem that you need to solve with, you're told what the trig is. So for example, that sine of 13 pi over 12, or you're given a word problem where you have to use your triangles in order to identify what the sum and difference is based on your parameters. So if you have any questions, please feel free to let me know. Otherwise, I do hope you enjoyed this video, and I'll see you next time.